All right. 6-4, direct proportion. And we will define our one term here, which is direct proportion. So what is a direct proportion? Direct proportions are probably the easiest of all the proportions. Basically, each lesson as we continue through will deal with a different type of proportion to, I guess you could say. But if I'm defining it as one quantity goes up or down, the other quantity moves the same direction. Direct proportion. It's one quantity goes up or down, the other quantity moves the same direction. Probably the best example I can give you of a direct proportion is if you have a job, and say your job pays you $10 an hour, right? So you get $10 for every 1 hour you work. And if I said, well, what if you work 3 hours? All right, how much money would you make?
$30.
3. And if we set it up here with a proportion, everything would look like that. But as the amount of hours I work goes up, what happens to the amount of money I make?
Goes up.
Goes up as well, proportionately, right? So as time work goes up, amount of money that you make goes for the same thing here. This is a direct proportion. As one goes up, the other goes up. If I'm driving a car 50 miles per hour and I drive it for 4 hours, how far did I drive?
200.
Right, 50 miles in 1 hour. And then if I said you drove it for 4 hours, how far did you drive? 200 miles. How did I get it? Again, I can use my cross products. X equals 200. That one was pretty simple. X equals 30. But this is an example of direct proportions. As one goes up, the other goes up. As one goes down, the other goes down. So we'll contrast these with some other proportions. Specifically, the opposite of a direct proportion is called an inverse proportion, and we'll deal with this later on this year. Inverse proportions are exactly opposite of a direct proportion. As one quantity goes up, the other goes down. They go in opposite directions, such as, again, just throwing out an example of like an inverse. Say it takes 2 people 30 minutes to shovel the lot out there. What if I had 4 people do it? What would you expect the amount of time it would take?
Less.
It should go faster. If 2 people take 30 minutes, 4 people would take 15 minutes, right? It would be, so as that number of people goes up, the amount of time to get the work done goes down. That's an inverse proportion. So this is the exact opposite. Inverse proportions are like 6-9, so we won't see them for a bit here, but this is the most common proportion. Definitely the easiest to understand. But so one goes up, the other goes up. Okay, why don't you flip over to your notes?
Okay.
There are not a ton of problems here.
Yeah, there's like, we have to do 1, 2, 3, 4, 5, 6, 7
So
problems.
number 3 deals more about this writing it 2 ways stuff we've done before. Keisha and Katie ran at the same speed. Keisha ran 3 miles, 21 minutes. Katie ran 2 miles in 14 minutes. Write the proportion. I'm not too into this like-unlike thing here. What matters is whether we get miles on top and time on bottom, measured in minutes. Keisha ran 3 miles, 21 minutes, 2 miles to 14 minutes. And if I use my cross products, that's 42 that way, that's 42 that way. The ratios or fractions are indeed equivalent. This forms a proportion. I could certainly have done it this way, put the time on top, miles on bottom. But again, if I'm going that route here, 21 minutes for 3 miles. Notice how all the numbers flip, because if I'm dictating time's going to be on the top, then my time numbers better be on the top, and vice versa. So, easy enough. Number 5. So here, we'll do similar lessons when we do scale models and similarity here, but they're trying to show, or basically you write the proportion that shows that these are proportionate triangles. How do we know? So they basically have these 2 triangles here, right angles. It says this is 40 meters, this is 24 meters, this is 60 meters. And we're going to get into the concepts of similarity and congruency and stuff like that here. But we're basically, what are we comparing here? The length to the height, or we're comparing 2 sides against each other. I'm just going to call them long side and short side. Is that fair? You can call it whatever you want. But I'll just say, I'll put the short side on top, long side on the bottom. So now, again, we're making proportions. Proportions should have 4 numbers. Conveniently, I have 4 numbers there. So you set it up. What am I missing there? I'm doing short side on top.
Oh, okay.
Really doesn't matter which one I do first or second, because again, the cross products, you should be able to prove it. You can check it with your calculator to make sure that your answer is good. What do I have over here on the left?
60 over 40.
Be the other way.
40 over 60.
The short side's on top. So 40 would be on top, because this is shorter than this, right?
Oh, it is?
May not.
Oh.
40 is shorter than, I didn't draw them all the
Okay.
scale, but 40 would be smaller than 60, 40
Okay.
is the short side. So then this one, what do I have for my 2 numbers?
24.
24 must be on the top, 30, because again, this is the shorter side, longer side, longer side. How do I know? Not due to my terrible drawing, but just due to the numbers. Book drew it a little more to scale than I actually did it. And if it truly does form a proportion, I should just be able to real quickly just check it. 40 times 36, 1440 over here. 60 times 24 is 1440 over here. Yep, that's my test. If you don't get the same answer on cross products, then you have not a proportion, just something else. But yeah, you could have did it the other way, the big number, but then,
I originally wrote it.
and again, that way, then I would have 60, or I could have 36 over 20. It does not matter here. But what does matter is, again, whatever you decide, that it just makes that equivalent ratio or proportion.
Yeah, I just wrote the bottom one.
Right, so again, and we could know, I mean, there's enough information here, Pythagorean theorem and all that, to figure out this missing side. And we would have a proportionate relationship between these sides too, as you would expect. So
What is is that A plus B equals C?
a squared plus b squared equals c
Yeah,
squared.
that one.
Right, yep, these are the a and b's, c is the long side, the hypotenuse. We'll cover that later this year when we get into our geometry, but what else do I have to tell you? Not much. Okay, average speed. Proportionate to find the average speed. So number 9 says, at what average speed does Adele ride her bicycle if she rides 28 miles in 3.5 hours? I'll probably just create a couple for you here. So at what average speed does Adele ride her bicycle if she rides 28 miles in 3.5 hours? So almost always, you're talking about miles per hour. So what is my ratio that I know to be true?
28 over 3.5.
Right, she goes 28 miles in 3.5 hours. What does it want me to figure out?
How how many
miles
miles
per-
is she doing in,
So then what do I need on my other side? What goes on top?
X,
Right, my variable, because this is what I'm trying to figure out, and what goes on bottom.
1.
Right, because I'm trying to figure out miles per hour. So now I can just use my cross products, solve it algebraically. And how many miles per hour does she ride her bike?
I got 9.3 repeating, but I think I might have done that wrong. I think I flipped it.
So cross products, 3.5x, 28 times 1 equals 28. Divide both sides
I
by
got
3.5. 28, oops, 28 divided by 3.5, 8. X equals 8. What's my label?
not miles
Miles
per hour.
per hour, right, 'cause that's what I figured out. Both my labels are here. Remember, miles, hours, 28 miles to 3.5. How many miles to 1 hour per hour? What was missing?
I see why I got it wrong. I didn't put the 5 in. I did 28 divided by 3 point. I forgot the 5.
There's 3 points.
It's 3 points.
How about this one here? Ball travels 125 feet in 8 seconds. What is its average speed?
So we're trying to figure out how many feet it goes in 1 second.
Right, feet
Okay.
per second. These are essentially unit rate. When you're talking about average speed or average rate, we're talking per hour, per minute, per second. It's a comparison between distance and time. So again, if I'm figuring out what the average speed is, Faith, what's my ratio I know to be true?
1, 2, 5 over 8.
Right, I know it's, and again, it's 125 to 8 seconds. Colin, what's the other side look like?
X over.
Right, for 1 second. Sam,
Yeah.
how many feet per second?
15.625.
Right, so use your cross products. 8x equals 125. Divide both sides by 8. You do get this as a decimal. You know what that is as a fraction.
Is it 6/8?
Close. 6/8 is 3/4. That's 0.75. 5/8.
Yeah.
Right. And then if I
I
label
figured
it
out how to
here,
turn a
I'm
decimal
talking
into a
feet
fraction.
per second. Or this way, feet, it's 625 thousandths. 625 divided by the greatest common factor is 125. 625 divided by 25.
5/8.
Right, when you simplify, but it's 15 and 625 thousandths. 625 over 1,000.
Oh, okay, yeah.
When I simplify, you should get down to 5/8. So these are one and the same. 0.625 and 5/8, one and the same, one and the same. Again, you can represent either way. Either way, is fine. Easy enough. Easy enough. And again, these are examples of direct proportions that went down. I could say it the other way. I could say, well, if I go 15 and 5/8 feet in 1 second, how far do I go in 8 seconds? And again, you could set that up here where you go 15 point, use over 1 second. If I would say, how far do I go in 8 seconds? You could set it up like that. It'd be 125, right? Or I could tell you, same thing, we know that ratio, say you went 125 feet, how long did it take you to go that far? But again, they're all cross products here. You'll just set them all up using cross products. It's just about getting all the numbers in the right spots and all. That door should be open. Never locked it. Hello, George.
Hello.
I even know. Why, yes, please.
Put it on the dog cam.
Let's see the last
Can I
portion.
have, is this one okay?
Mm-hmm. George, put it on the dog cam.
This is good there.
Christine else is gonna go,
I'm gonna put it on the
zesty.
dock cam. Ooh, zesty, look at that. I'll zoom in on it. Let's see what it looks like up close. Look at that thing. Holy smoker. Thank you, George. I appreciate
Oh my
it. Thank you,
God.
Roland.
That looks so good.
Doesn't it?
Can I have a tiny chunk of frosting?
Not right now. We'll see how the rest of this goes.
Sprinkle.
Come
Sprinkle.
back to this
Just
later
two.
here. Okay, so, yeah, I mean, again, it just, the whole name of the game here is set up, write these proportions, this chapter, right?
Right.
Last part here, I have this little graph here, I suppose. They talk about a rate, straight line, in any proportions, if you plot the points here, it will always make a perfectly straight line. If it doesn't, you don't have a proportion. So what they want us to do here is they basically say, they give us this nifty little graph here. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4.
Graph.
And again, is mine drawn perfectly to scale? No, it is not. No, it is not. So, close enough though. You can do this. So, what it says is they graph out the number one there, and I could graph the X and the Y. One t-shirt, down here, t-shirts, cost per shirt. So one t-shirt's $15, right? Number 13, 3 t-shirts for $45, 3 for 45. How much do you think 4 t-shirts would cost? Think it through.
60!
Right. And this graph doesn't keep going, but what do you think would come next after 4?
75!
And then up here, and then 5 would be 70. But if I did draw a line, and again, if this was perfectly perfect in its creation, the line would perfectly pass through, and when you do it over here, you'll notice that there. But this is a proportion. I could use this graph, probably wouldn't make the most sense, but I could keep it going here at its rate. If the paper went far enough, I could go up to 12, 13, 14, 15, you know, right as far as I want, and ditto it this way here, and just match up how much t-shirts and costs would be, because they all are, for every t-shirt we add $15 to the cost. Right? Right? Okay. Do the word problem, because again, notice that's 14 there. So how many problems does that leave you at? 1, 2, 3, 4, 5, 6, 7 problems.
That's too many.
I don't
That's
know
too
how
many. We need
Most of them shouldn't take that long. So,
How dare you give us 7?
questions?
No.
You have about half an hour. Finish your test correction. What?
Show the donut again.
Why?
Because we gotta see the donut.
There's the donut again.
No, I want a sprinkle.